Hello everyone. So today we are going to see DP on subsequence patterns. So I'll start with the basics like what is DP on subsequence and how are we going to solve the problems. So in this I'll talk about both these approaches, top down approach and bottom up approach. In some of the cases, bottom up approach or the tabulation approach will be more useful to you. So it's better to have an idea on what is bottom up approach in this type of cases. So you'll get a better understanding when we do the bottom up approach of this rather than the top down approach. For sure, top down approach is easy to write, but then the bottom up approach will get you better understanding. Okay, so basically the simpler question says that you are given an array. Okay, this has some numbers, let's say 2, 5, 7, 1, 3, 6, and you will be given some sum which is equal to, let's say, 13. Okay, and this could be sum or target or whatever variable, and you need to find a subset. Okay, find subset from this array which equals this sum, which is equal to this sum, which is equal to sum. Okay, so your pattern lies under this. Like you need to find the subset which is equal to the sum or target variable which is given to you. It could be 5 plus 7 plus 1. Okay. Now it could be anything else like uh 136 is it 13? Not possible, but there are many subsets. Then you need to find whether true or false. Just true or false in this case, whether it is possible to get this target sum out of this or not by finding any subset. Okay, by finding any subset. Now, what we are going to solve the problem is another variation of it, a simpler variation of it, which is there in the lead code, which says that you are given this array simply. Okay, let's take the array as from here only 1, 5, 11, and 5. Okay, 1, 5, 11, and 5. Now, they haven't given any sum or target variable. They have given that you have to partition this array, okay, into two subsets such that the sum of both these uh, partitions are equal. So, for partition 1, sum 1, okay, you will get. For partition 2, sum 2 you will get. And this should be equal, like sum 1 should be equal to sum 2. That's what they have mentioned, that you need to do it in such a way that both of these are equal. Now can we partition it so that the sum could be equal? Like yes, I can make this 155 in one of the subset and 11 into another subset. So I'll make two subsets out of this. Okay, partition equal subset sum. I can make two subsets out of this. One could be of 155, another could be of 11. This is also 11, this is also 11. So I'll return true that I can make two subsets. Okay, which, so this is not subsequence. Okay, subsequence should be continuous. Like once you have taken 1 5, you cannot jump and take this. But for subset you can take anything, like you can jump 11 and take 5 and take 11 in another subset. Okay, so both of the sums are equal. That means you will return true. So you are not provided sum, but what you need to do is you will find this sum, okay, this total sum of the array, whatever is given to you, and you do its divide by 2. So first you check whether this is even or not. If it is not even, for sure you cannot partition this into two parts. If it is even, just find whether we can find sum by 2 by the above method, like sum by 2 from this whole array. I can find any subset with this sum by 2. If yes, then another leftover part will of course be another sum by 2 value only, right? So this is what the core logic lies inside this. Now we'll come to two of the approaches. So we will understand the main question only, subset sum equal target only. Okay, that you are given an array and you need to find the, so now you got the target over here, like here you got 10 plus 1, 11 plus 11, 22. So 22 by 2, 11. So your target is 11 in this particular question. Now let's take this question only. Okay, what are the changing variables I have? Let me change the color. What are the changing variables I have? I have I and I have a sum. These two are my changing variables. Okay, I can make a 2D DP of size n plus something and maximum sum plus something. Okay. Now let's say I had made this DP. Now, what could be my base condition here? Like we will pass 0. So that means I have to find true or false. So whether sum could be made from subset I to n of array for sure. Okay, this is my DP of I comma j implies 2. So whether some j, okay, I could say whether some j could be made from subset I to n of the array. Okay, so my base condition is like if uh, I is equal to n, that means I have reached the end of the array. Okay, and if my sum is 0, that means that is true. So I'll return true, otherwise false. Otherwise false. Like I've completed my array, but I didn't find the sum is 0, so I'll return false from that particular point. Now you have two conditions. Okay, what are the two conditions? Take, not take. But here it's not given that you can take the ith variable infinite times. No. Once you have taken, you have to go move ahead only. So you have two variables. Okay. Initially take is 0 and not take is also 0. Okay. Now if you will take, it will be what? Solve of, you will take it. So solve of I plus 1, sum becomes sum minus array of I. Okay, and when this could take condition could happen, if your array of I is less than equal to your sum, then only you can take it, comma whatever is your array. So this is your take condition. Okay, and your not take condition will look like simply this, and sum remains same, like no change in the sum. This is your not take condition. And what will be your DP of I comma sum will be, your DP of I comma sum will be take or not take, because this is true or false, right? So this will return either true or false. 1 means true, 0 means false. That's what we assumed. Okay, and we will return solve of 0 comma sum passing the array. I hope you got this. I hope you got this. Now we'll understand the bottom up approach of this. Like, okay, now what could we do with the help of tabulation? Okay, I've made a 2D DP. Okay, let's say my size is 4 here, and and I'll make the size of maximum sum. Like here my sum is total sum is 22. So I'll make the DP of size 5, let's say not 4, 5 comma 23 as of now. Okay, fine. So that I get exact value of 4 and 22. Okay, by index changing. Okay, now what could be your base conditions over here? So you will make this array. Okay, this is 4 rows and some 22 columns. Okay, okay. So initially you will fill up this values, okay, this and this values, and based on that you will find out this values. Okay, like based on this I'll find out this values. I need some base values first of all. Okay, so I'll consider I equal to 0 as not your index array I 0, but I'll consider I is equal to 1 as your index array of 0. So I'm taking 1 based indexing rather than 0 based indexing. But your array is given in 0 based, so we'll do I minus 1 at that time. I hope you will get that much logic. Okay, so when my I is 0, now I had made this array. So for base condition, I'll run the loop for I is equal to 1 till I less than equal to n, I plus plus. And for j is equal to 0 till j less than equal to sum and j plus plus. Okay. Now, what could be your base condition? If your I is 0, and that means no element of array you are taking. Your array of 0 means your I is 1. Okay, I'm considering that way. So, no array of element you are taking. So, your DP of I comma j, be it any sum, it could be always false only because I'm not taking only any element. If it's 0 sum, then also it should be false only. No, if it's 0, it should be true. Not taking any element and sum is 0. But that will be covered in J part. So if your J is 0, okay, if your J is 0, that means if your sum is 0, then whether you will take any element or you will not take any element, that doesn't care, and you will put your dp of ij true over there. So zero sum is possible by taking empty subset. Okay, by taking empty subset. A zero sum is always possible by taking empty subset. So this could be true. So now your array looked like this way. Okay, so this is your I is equal to 0 and this is your j is equal to 0. Now this looks true and this looks false. This is how your initial base array looked like, DP array looked like. Now what you will do? Now to fill this value, okay, again you have two conditions. So this is what? I is equal to 1 means your array is array of 0 value, which is 1 in our case, 1, 5, 11, 5. Okay, so array of 0 is 1. Okay, now you need to decide on all the possible sums, like what are possible sums I can make out of this by taking this, by not taking this. Okay, I'll run loop again for I1 to n. So this is my index and my element will be array of I minus 1. Okay, and I'll make a loop of j is equal to 1 till j less than equal to sum and j plus plus. Okay, because j is equal to 0 is filled. So now when can you take it? If your array of I minus 1, this is your actual value, is less than equal to your sum, like what we did in the top down approach, similar way. Okay, then you have take condition. So what you will do? dp of ij is whether to take it or to not take it. You have two conditions. If this is satisfied, if array of I minus 1 less than equal to 0, you have two conditions. Okay, to take or to not take. If you will take, it will be what? The sum until the previous value. Okay, okay, so if you want this sum, this, oh sorry, if you want this j sum as j, then from 0 to I minus 1. Now here dp of ij means subset with some j from 0 to I of array. Okay, because we are putting base condition at 0 values, at starting values. So if you want this sum to be j, then from the previous, until previous index, until 0 to I minus 1, you have to give j minus array of I minus 1 if you want to take it, or if you didn't want to take it. So if your array of I minus 1 less than equal to j, you have two conditions, whether to take or to not take. If you didn't want to take, of course, you have to take this j sum only until, so from previous only you took j sum, so no need to take the current one. This way you are taking array of I minus 1, so from previous 0 to I minus 1 you have to take j minus array of I minus 1 only. Okay, else your dp of ij is only not take, which is nothing but I minus 1 j. So this way your dp will be filled. Okay, so your dp of ij indicates what? If true, then a subset from 0 to I has some, is from 0 to I has some j possible. This means that. And if it is false, that means it's not possible. Okay, so it could look something like these all values are true and these all are false. Okay, now it could be true, false, true, true, false, 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 true, true, false. Okay, and your ending value represents what? Whether true or false, if we take subset from 0 to n by taking the full array, is there any subset which we are getting with sum? With sum as sum. With sum as sum because it's last column. And by taking full subset, whether I'm getting it or not getting it. That's what I wanted to check. Okay, if I'm taking this subset 0 to I and this sum, whether I'm getting true or false. So you will return here what? You will return here dp of n comma sum, because this is bottom up approach. There you have written what? Solve of 0 comma sum. I hope you got. Okay, so this feeling of values like true, false, and all will be able to use in the next questions. We'll solve in the next video maybe. So you'll get a better idea like why I made you learn the bottom up approach. This part, if you have understand like okay what this actually mean in the bottom up approach, you'll be able to solve the next questions which we are going to see. Okay, let's just solve this question in. Okay, so we'll try and solve the bottom up approach only. Fine. I have int n is equal to nums dot size. I'll make one sum. So what I'll do is I for int 0 to ni plus plus sum plus equal to nums of I. Okay. Now if this is equal subset sum. So first you need to check if sum mod 2 is not equal to 0. Okay. Means if it is not even, you will return false from here only. Okay. Now I'll make a vector of int dp. Now my target sum. Okay, so I'll make this sum as sum by 2. Okay, so I've divided it by 2. That is my target sum now. I'll make n plus 1 and sum plus 1 size and initialize it with 0. So false values. Okay, now base condition. So I 0 till n and your j is sum. J 0 till j less than equal to sum. What we will do? If I is 0, dp of ij will be false. If j is 0, dp of ij is true. Okay. Now for int I is equal to 1 till I less than equal to n and j1 till j less than equal to n, we have to fill each value one by one. So if my current value, which is I minus 1, is less than equal to j, I will take dp of ij as dp of I minus 1 j minus array of I minus 1 or I minus 1 j. Else only not take. If it is greater than, we have only one option of not take, so we'll take not take. Okay, and we will return what? Dp of n comma sum, because here sum is sum by 2 only by default. Okay, I hope you got this and this is very useful. Okay, this is nums. Okay, so this should be nums. This should also be nums. Oh, this should be sum, right? This should be sum. Okay. So we'll solve so many questions like this in the next video, wherein the bottom-up approach will be useful to you. So stay tuned for the next video. Bye-bye.